This is Algebra 2, Chapter 1, Section 2, in which we study properties of real numbers. Real numbers are just the numbers you already know. They're whole numbers, they're fractions, they're decimals, they're square roots, they're everything you already know about. There are many subcategories of real numbers. Under the group of real numbers, which we call R, for real, there are two kinds of numbers. There are irrational numbers that we call I, and there are rational numbers that we call Q. Q for quotient, because a rational number can be written as a fraction. Inside the group of rational numbers Q, we have the set of integers, which they use the letter Z for. I have no idea why. Inside integers, you have whole numbers, W. Integers are positive and negative whole numbers, -2, -1, 0, 1, 2, etc. Whole numbers are 0 and the positives, 0, 1, 2, 3, 4, 5. And then there's natural numbers, which we use the letter N for. That's just 1, 2, 3, 4, 5. So natural numbers are the ones you learned how to count with, 1, 2, 3, 4, 5, etc. Whole numbers, you put 0 into the group. Integers, you add in the negative versions of the whole numbers, -5, -4, etc. Rational numbers are anything you can write as a fraction, any numbers that you could make a fraction out of. That includes decimals that stop, like 0.25. It includes decimals that repeat, 0.33333333. It also includes fractions. Irrational numbers, on the other hand, are the ones you can't make a fraction out of. They're like pi. Pi is 3.1415926 blah blah blah. And it goes on and on forever and it never repeats. Something like the square root of 2. Okay, the log of 8. Things that don't come out clean are irrational numbers. Now you see this pretty picture here. If you're a picture type of learner, then this picture could help you. The natural numbers are located inside the group of wholes, but there's something in wholes that's not natural, 0. The two groups, the naturals and the wholes together, are inside the integers. All of those things, natural, whole, and integer, are inside the rationals. And then the irrationals are stuck on the outside. And this whole outer box is your real numbers. And for whatever reason, it likes to add a blank page sometimes. So I've got the same picture here to help us find things. Our job is to name the sets of numbers to which each one belongs. So we have something like -23. Where does -23 fit? It's not a natural number. It's not a whole number. It is, however, an integer. Well, since it's an integer, integers are also inside rational, and everything is inside real. So Z, Q, and R, integers, rationals, and reals. The square root of 50, I punch on my calculator and I get 7.07 blah blah blah. That's not a rational number, so it fits into irrational. And then also reals. -4/9 Certainly not a natural number. It's not a counting number. It's not a whole number. It's not an integer. So it only fits the description of being rational, because it's a fraction, and real. And then our last one of this type, we have a number like 2. 2 is a natural number, which also means it counts as a whole number, which also means it counts as an integer, which is also rational, and then it's in the whole group of reals. So you have a whole bunch of lists there. When they ask you these kinds of questions, name the sets to which the number belongs, you have to give every set that it fits in. If you use the picture, find the innermost group that it fits into and then work your way out. And remember, everything that we have so far will fit into reals. There are some numbers that don't fit real numbers, but we'll learn about those later this year. And there are also some properties of mathematics that we need to be aware of. And you've seen these before, you probably just don't remember them offhand. But the commutative property, commute means to move. So the commutative property lets you move things around. What this property says is A plus B is the same as B plus A. I can switch the order of the numbers when I'm adding, and it's okay. Doesn't change anything. And the same holds for multiplying. You can switch the order, and it's okay. 7 times 4 is the same answer as 4 times 7. The associative property, associative is like associate, which means to group. So it says you can change the grouping. If I'm adding a bunch of numbers together, I can add B and C together first, and then add that to A. Or I could add A and B together, and then add that to C. You've been doing this for a long time and not thinking about it. When you have a list of numbers to add up, and you see an 8 in the list, you look for a 2 to make a total of 10. And you're changing who's grouped together. And the same thing works for multiplying. The identity property, identity is keeping something the way it is. So the identity property is if I add 0 to a number, I get the same thing back. Whatever A is, if I add 0 to it, I get A. So 0 is the additive identity, it's the addition identity. 1 is the multiplication identity. And then there's this idea of inverse, and you're familiar with this also. A plus the opposite of A makes 0. A and negative A are inverses. For multiplication, it's 1 over A would be the inverse of A. You know this term as reciprocal. And then everyone's favorite, the distributive property. And the distributive property says if I have B plus C in parentheses, it's the same thing as multiplying A times B and then A times C and adding it together. Okay, you're distributing this A to both terms. So they're going to ask us to name the property that the statement shows. So we're going to have to look at that list of properties that you just wrote down on the last slide and decide which one this is. So for example, our first one here, we go from 5 plus 4 plus 13 to 5 plus 4 plus 13. What's changed? We've changed the grouping. When you change the grouping, that's called the associative property. Okay. What about this? We've got 2 times x plus 3 is the same as 2 times x plus 2 times 3, which is 6. What did we do? We distributed the 2. So that's distributive property. One more of these. We have 8 times 2 is the same as 2 times 8. All we did was switch the order. When you switch the order, when you move things around, that's commutative. And then the last idea we need to look at is the additive and multiplicative inverse of things. So they've given me the answer -5, or the number -5/8, and they want the additive inverse and the multiplicative inverse. Well, the additive inverse is easy. It's the opposite. Change the sign. So it was -5/8, it becomes +5/8. The multiplicative inverse, remember I said on the other slide there, that's the fancy term, is reciprocal. So they gave me -5/8. I do the reciprocal and I get -8/5. Okay. What about 1 1/2? Additive inverse again is easy. Change the sign. 1 1/2 becomes -1 1/2. The multiplicative inverse gets a little bit trickier because we have a mixed number, but that's okay. We can make this into an improper fraction. 1 1/2 would be the same as 3/2. 2 times 1 is 2, plus 1 is 3, 3/2. Well, the reciprocal of 3/2 is 2/3. So we classified numbers into their assorted sets. We've looked at properties so that we can recognize them when we see them. And we found inverses, both additive and multiplicative. As always, if you had questions, I hope you wrote those down and bring those with you. And we will see you in class.